In this video lecture, we will go through formaldehyde, preparation of formaldehyde, its physical properties, and then we'll look some of its chemical properties. We'll look how formaldehyde is different from other aldehydes. Right? For preparation, we'll look into its lab preparation, then its industrial preparation. So for lab preparation, first let me just write down, we are going to study about formaldehyde, its lab and industrial preparation. Right? For lab preparation, it is prepared by oxidation of methanol. Right? We take methanol vapors and air. Both methanol vapors and air is passed over heated platinized asbestos or silver. Right? Where both react, that is methanol and air will react, that is methanol will get oxidized to form formaldehyde. Right? So let me just write down the equation, then we'll look into its lab setup. CH3OH plus oxygen, right? It is passed over platinized asbestos or your silver, where it will form HCHO. Right? This is the chemical equation for your formaldehyde. Right? For the preparation of formaldehyde. Let's balance it. Right? Now we'll look into the setup, how methanol vapors and airs together are passed over platinized asbestos and how we prepare formaldehyde. Right? What we do is we take round bottom flask. Right? We take like this round bottom flask. Right? In this round bottom flask we have methanol. Right? Now this round bottom flask is placed like this on a water bath. Right? And this round bottom flask has two openings. Right? And through these two openings, you can see there are two tubes. Two tubes bent at right angles are passed. Right? Then you have other tube like this. So from here you get air from outside, right? And this tube is going into this round bottom flask where you have methanol liquid. Right? Now this tube, the second tube, which is bent at right angles, right, is connected to a combustion tube like this. Right? It is connected to a combustion tube, and then again there is another tube coming out of this combustion tube like this. Right? Where you have it's not exactly like this. Right? It's like this. So you have water in this. Okay. Right? And now this is your combustion tube, right? That has platinized asbestos or silver. This platinized asbestos or silver is in this combustion tube. This is your combustion tube, right? And here in this you have methanol, this, and from here outside you get air is sucked in, right? And this combustion, this round bottom flask would be heated with a burner, right? This is heated with a burner. Now look at this equation and then look at this setup, right? It's easy to understand. Your methanol vapors is in this round bottom flask, right? Your oxygen is sucked in from outside, and this burner, this is your burner, right? This burner is, let me just write it down over here. This is your methanol, right? This burner will heat this methanol contained in this round bottom flask, right? Now when this methanol is heated, it will form its vapors, right? So methanol vapors along with oxygen, right, will go into this combustion tube, right, through this tube, right? You have two tubes, this tube, first tube through which air is sucked in, the other tube which is connected to combustion tube, and through this tube methanol vapors, right, through this tube methanol vapors and oxygen, right, is passed into your combustion tube, and this combustion tube is also heated. You have a burner here, right? This combustion tube is also heated. Now this is heated to heat the platinized asbestos or silver that you have inside this combustion tube. So you have heated platinized asbestos here, right? Now over this platinized asbestos, your methanol vapors and oxygen will pass, right? When methanol and oxygen will pass through this combustion tube, right, that contains your platinized asbestos, your methanol will oxidize to form formaldehyde, right? So here formaldehyde will form in this combustion tube that will pass through this tube into this flask, right, that contains water. So this formaldehyde that gets formed will dissolve in the water, right, which is in this flask, right? So you have HCHO dissolved in water, right? When formaldehyde is dissolved in water, we call it as formalin, right? So this formalin contains 40% water, right? I hope this is a simple setup and is clear to you. So formaldehyde vapors formed on account of oxidation of methanol, right? Oxidation of methanol are absorbed in water, right? Formaldehyde will be absorbed in water here, right? It will get absorbed in water. The aqueous solution of formaldehyde obtained, right, contains 40% formaldehyde and is known as formalin, right? Like I said here, this formaldehyde that gets formed is absorbed in water, and 40% formaldehyde solution in water is known as formalin. So this is how formaldehyde is prepared in lab, right? Now if you want to look at its industrial preparation, in industrial preparation formaldehyde is prepared by oxidation of methanol only, right? It is passed over heated copper to form HCHO plus water, right? The only thing that differs here is you take a copper catalyst which is heated to 825 to 875 kelvins, 825 to 875 kelvins, right? Now there is another way. This is for industrial preparation, right? Remember, there is another way to prepare formaldehyde is by controlled oxidation of methane, right? Just remember the equation for this. You take, what we do is by controlled CH4 plus oxygen, right, under pressure, right, and your catalyst is molybdenum oxide, you get HCHO, right, by controlled oxidation of methane. This is your controlled oxidation of methane, right? This is also your industrial preparation where methane gas is oxidized, right, under pressure, right, using molybdenum oxide catalyst, where this methane will get oxidized into your formaldehyde, right? So these are two industrial methods for the preparation of formaldehyde. First is oxidation of methanol in the presence of copper catalyst at 825 to 875 degrees Celsius. No, sorry, Kelvins, not Celsius, Kelvins, right? Where it forms formaldehyde. Then you have controlled oxidation of methane in presence of molybdenum oxide under pressure. It forms formaldehyde, and this is your lab setup for the preparation of formaldehyde via oxidation of methanol, right? In presence of platinized asbestos or silver, right? Just remember this setup. You have formaldehyde here, which is heated. You have methanol here. You have methanol here, which is heated to produce methanol vapors. Air is sucked in from outside via this pipe, right? When both methanol vapors and air will pass into this combustion tube and will get oxidized via this equation to form formaldehyde, which gets dissolved in water here to form formalin. When the solution of formaldehyde in water, 40% solution of formaldehyde in water is formalin, right? Now just let's look into some of its physical properties. We know that formaldehyde is a gas, right? It's a colorless, pungent smelling gas. Boiling point 252 Kelvin, right? It's a colorless, pungent smelling gas. Boiling point is 325 kelvins, right? I hope this is clear. Sorry, boiling point is 252 kelvins, right? And one other important property is that we have discussed this already, that 40% solution in water is your formalin, right? Why? Because it is soluble in water. So formaldehyde is soluble in water, and 40% solution of formaldehyde in water is your formalin, right? And the other important property is that in the gaseous state as well as in your aqueous solution, right, it's a powerful disinfectant. Remember, it's a disinfectant, right, in gaseous as well as in water solution, right? Now let's talk about some of its chemical properties. Chemical properties, it gives normally all reactions that are given by other aldehydes, right? And it gives addition reaction with HC, hydrocyanic acid, HCN, and sodium bisulfite, and it gives condensation reaction with ammonia and other ammonia derivatives. Now there are some different reactions that are not given by aldehydes. We'll be discussing those reactions in a different lecture. I'll give you a brief picture. With ammonia, formaldehyde will form a compound known as urotropine, right? This reaction is not given by other aldehydes, right? And there are some polymerization reactions of formaldehyde, right, where it forms paraformaldehyde when the aqueous solution of formaldehyde is evaporated to dryness, right? And when formaldehyde solution is treated with concentrated sulfuric acid, it polymerizes to polyoxymethylene, right? And when formaldehyde gas is allowed to stand at room temperature, 3 molecules polymerize to form metaformaldehyde, right? So these are some important polymerization reactions which we'll do in a next video lecture, right? I hope all this is clear. Thanks.